All right. Testing. 1, 2. Okay. Welcome back to Fundamentals of Philosophy. Once again, I'm your instructor, John Taylor. We are going to be working this week with the principles of philosophical reasoning. So for this one, it's going to be a little tricky to do this solely as a video or audio lecture. I strongly encourage you. We're going to be dealing with some syllogisms. Premise 1, premise 2, conclusion kind of thing. It's a lot easier if you can actually see that stuff in front of you. So, I'm going to send out a PDF copy attached to this file. If you want to watch the video while reading along with the PDF, that might be the best way. Either way, let's jump into it. So, Module 2 is on reasoning, and in this module we will take a closer look at two methods of reasoning that philosophers employ to uncover and investigate the general and fundamental questions of philosophy: deductive and inductive reasoning. So that's one of the big things that we're going to be covering here. This will be important for the graded portions, is the difference between deductive and inductive reasoning. So we're going to kick things off with a brief introduction into the history of philosophical logic, because that's what we're going to be dealing with, especially with deduction. Induction deals more with the scientific process, the scientific method. Deduction deals more with philosophical logic. So let's jump into some logic. Let's talk about the history of logic. So the first method is what's known as deductive reasoning. Deductive reasoning is the cornerstone of classical logic, which, as the name implies, traces its roots back once again to the ancient Greeks, this time to Plato's student Aristotle. And we'll be talking more about Aristotle in one of the later modules. He's a hugely important figure in the history of philosophy. And philosophy loves to sort of divide things into competing schools. And from the ancient Greeks, you have sort of the Platonists on one side who sort of describe everything in terms of these abstract forms, and then you have the Aristotelians on the other side who are very much grounded in empirical experience of the world and believe that you build up your theories and you build up your knowledge of the world from your actual experience of the world. And this split becomes sort of encoded as the rationalist versus empiricist split that we'll talk about more in the next module. So this is going to be a big sort of division that runs through the course. But in this case, we're talking about Aristotle in his role as the sort of progenitor of philosophical logic. Aristotle's work laid the foundations for formal reasoning, introducing syllogisms as a systemic way of deriving conclusions from premises. And we'll take a look at what a syllogism looks like. And jumping ahead a bit, in the 17th century, Gottfried Wilhelm Leibniz, was the first to envision a system of formal symbolic logical notation, which influenced the logic that we all know and love today. Leibniz hoped that this system would serve as a universal language for reasoning, eliminating disputes by reducing arguments to calculation. So, I mean, the idea, sort of going back even to Leibniz's time, is to reduce disputes to something that can be solved in a mathematical way. And this is the sort of rationalist project that we'll look more at in the next module. So notably, Leibniz also invented mathematical calculus. This is sort of just in a historical aside. At the same time, and independently of Isaac Newton, and they actually had a huge dispute over who plagiarized who. No one plagiarized anybody. They both did this on their own and discovered calculus independently. So if anyone is taking calculus, blame Leibniz and Newton for that. They're the guys responsible for this. But that's a whole other story. And we'll be looking at Leibniz again in the context of philosophical rationalism in Module 3 coming up. So, fast forwarding once again to the late 19th century. And again, we're talking about sort of the history of logic. We're skipping over a lot of stuff because we don't need to get into, like with Aristotle, the big thing was the law of non-contradiction, the excluded middle, things like that. We're not going to be getting that deep into it. We just need to know him as the sort of guy who came up with the syllogistic form. And then Leibniz is the guy who gets the idea that you can symbolize this whole thing, can convert it into something like a mathematical formula. And then in the late 19th century, you have a guy named Gottlob Frege, who revolutionized logic by developing what's known as the predicate calculus, which is the logic philosophers use today. It's a system capable of analyzing the logical structure of more complex statements. Frege moved beyond Aristotle's syllogisms by incorporating variables, quantifiers, functions, a whole slew of things that we're not going to cover, fortunately. Although if you want to take a deeper dive into advanced logic, either Aristotelian or some of the other forms, I encourage it. It's actually fascinating stuff. Frege's logic, the predicate calculus, enabled the expression of a far wider range of arguments, so you could do a lot more work with it. His work profoundly influenced early analytic philosophers such as Bertrand Russell, who we met last time. So, in contemporary analytic philosophy, symbolic logic, which is logic that is expressed in a symbolic notation, like a sort of mathematical notation, is a crucial tool for representing arguments in a precise and universal symbolic language. So anybody, theoretically, anyone, given the tools of logic, given the symbols, given the relations and the formal structure, anybody should be able to retrace the steps. It's like math, you plug and chug. And you can reduce any statements about the world into a logical form, and then arrive at a true conclusion, a necessarily true conclusion based on the premises. That's the idea. So by formalizing premises and conclusions, philosophers can analyze arguments according to general rules of deduction and inference. So today, logic continues to evolve, branching into specialized fields such as modal logics, which explore necessity and possibility, possible world semantics, which are related to modal logics, non-classical and paraconsistent logics, which handle inconsistencies, and even quantum logics, inspired by the principles of quantum mechanics, which gets into some really far-out stuff. Each of these developments has extended the boundaries of what logic can represent and analyze. So in this class, we're only going to be dealing with a few basic principles of what's called classic Aristotelian logic. A lot of it was developed after Aristotle, but it's still he still gets his name attached to it because he's the guy who sort of came up with the basis for all of this, as far as we know, as far as the record goes. So we're gonna kick it off with deductive reasoning and look closer at that. So deductive reasoning, and again, deduction versus induction is one of the things you want to sort of drill into your head for the graded portions. Deductive reasoning is top down, and that's one of the big differences. Is induction is going to be bottom up, deduction is going to be top down. So what that means is it starts with a general principle and proceeds step by logical step to establish a specific conclusion. So it's going from the general to the specific. You start with the big, with the abstract, and then you drill down to the concrete. If properly constructed, a deductive argument is necessarily true. It is impossible. It should be impossible to arrive at a false conclusion from a properly constructed deductive argument. So if you do everything right, and we'll talk about what that means to do things right, then you should arrive at something that is necessarily true. So it's a very powerful tool. Arguments can be analyzed logically into a formal structure that proceeds along lines of inference from premises to conclusions. So these are the logical relationships that tie premises together to establish a conclusion that you're trying to get to. So consider this classic example, which we will call syllogism 1, so S1. And this is the stuff that you're going to want to look at the handout for, at the written version of these notes, which I'm going to attach this one as a PDF. You can search it, you can refer back to it. It's open book for the graded portion, so you can refer back to it if it's helpful there. If it's not, don't. There's lots of other materials that we have that you can also look at. But this is S1. This is our starting syllogism. This is a valid syllogism. It's kind of the classical example. Premise 1, all humans are mortal. All right, we're starting at the general, starting very top level. Premise 2, Socrates is a human. Conclusion, therefore, Socrates is mortal. And look for that therefore. Look for therefores and thuses and other words like that in conclusion. And this is because part of most people do not speak in logical syllogisms. Most people, especially in our mediated sort of postmodern environment or post-truth environment, embed their premises in a lot of verbiage which can be difficult to break apart. So figuring out how to derive premises from ordinary language is part of what the logicians are up to. It's part of what philosophy is up to. So, again, premise 1, all humans are mortal. Premise 2, Socrates is a human. Conclusion, therefore, Socrates is immortal. That does seem to follow necessarily. You can see inferentially how you can move from P1 to P2 and then arrive at C. If P1 and P2 are true, then are valid and sound, and we'll talk about what those mean, then you can't avoid getting C. C follows necessarily. So, usually premises and conclusions don't come neatly prepackaged into simple syllogisms like S1. It takes some work and analysis to tease out what the conclusions are that you're being sold and what premises are being used to sell them to you. So this is one way to cut through sort of the BS, for lack of a better word, that's out there, and figure out whether or not the arguments people are making are actually sound, or actually valid, or actually good arguments, and differentiate from good and bad arguments. Once these are teased out, the arguments can then be formalized into the syllogistic structure and tested for validity and soundness. And this is the next sort of two things you want to keep in mind: validity and soundness. So you've got induction and deduction. Now, validity and soundness. Validity is a formal property that refers to the structure of an argument. Anytime you hear the word form or formal within a philosophical context or a logical context, you are talking about the structure. And that is to be opposed to the content, which is what it's actually about. The sort of the formal structure is the way that the parts of the argument logically relate to each other structurally in order to get the proper inferential relationships and arrive at the proper conclusion. It has nothing to do with the content of the actual premises. As long as the structure is correct, then the argument is valid. If the argument is properly formed, then it is valid, regardless of the truth of its components. So S1, for example, is valid because the inferential relationship between its premises is such that if P2 and P2 are both true, then it is logically impossible for C to be false. C is the conclusion. So if your premises are both true and they are arranged in a valid inferential relationship, then it's impossible to come out with a false conclusion. But to see an alternative, let's look at another syllogism S2. Premise 1, all humans are immortal. Premise 2, Socrates is a human. Conclusion, therefore Socrates is immortal. That's deductively valid. And again, that's because this deals with the formal structural relationship. It has nothing to do with the content, with the actual truth of the statements. But it's arranged in such a way that if you accept the truth of all humans are immortal, and then accept the truth of Socrates is a human, then you arrive at the conclusion that Socrates is immortal. Socrates was not immortal. In fact, he was killed. In our last module, we killed Socrates. So we know that that's false, but it's a valid argument. The structure is valid. So the truth of C is guaranteed if P1 and P2 are both true, but the argument is not sound because P1 is not true. Socrates or all humans are not immortal. And this is, again, validity and soundness are the two things we want to look at. Validity refers to the structure. And soundness refers to the truth of the actual content of the argument. So while validity is concerned with the structure, soundness considers whether the content of the premises are actually true or false. To be sound, an argument must both be deductively valid and its premises must also be true. So you can't have an invalid argument that's sound. You have to have validity and a valid structure, and you have to have true premises. And if you have both of those things, you have soundness. And then you get to the big part, which is that if a deductive argument is both valid and sound at the same time, if it's got both of those properties, then it is logically impossible for it to contain a false conclusion. You're guaranteed to get truth out of this equation just by the mathematical relationship, just by the structural relationship of the premises to the conclusion. It's a necessary fact just by the way it's structured. So, therefore, deductive validity and soundness together guarantee the certainty of a conclusion. And that is going to be a big difference between deduction and induction, which we will get to in a little bit. An argument can, however, be both invalid and unsound, and yet still contain a true conclusion. That's weird, right? Consider S3. All humans are, premise 1, all humans are immortal. Premise 2, Socrates is a cabbage. Conclusion, therefore Socrates is mortal. There's some problems with that. So S3 is neither valid nor sound. The conclusion cannot be validly inferred from P1 and P2, so the argument is formally invalid. It does not follow from the two premises, all humans are immortal, P1, combined with premise 2, Socrates is a cabbage, does not entail the conclusion that therefore Socrates is mortal. You don't get Socrates being mortal out of immortal humans and cabbages being thrown in. It doesn't work. Additionally, P1 and P2 are both false. All humans are not immortal, and Socrates was not a cabbage. Although someone may have named their cabbage Socrates. You never know. So the argument is not sound because its premises are false. So it is neither valid nor sound. But the conclusion that Socrates is mortal, it's true. It's a true conclusion. It just happens to be true, and the fact that it's true has nothing to do with the argument. The argument is a bad argument. The argument is terrible. And you can think of many examples, I'm sure, in life where people have accidentally said, come out with something true, accidentally said a true thing on the basis of really, really bad reasoning, on the basis of an argument that simply does not work. And yet somehow at the end they come out with, purely by accident, by saying something true. Stopped clock is right twice a day and all that stuff. So that is soundness and validity. The next pair of logical concepts that, and this one, this is necessity and sufficiency, necessary conditions and sufficient conditions. This trips everybody up. This sometimes trips me up. But it's central. It's something that you really want to try to master, not just for philosophy, but honestly in life. It's we're going to see it a lot in this course, moving through the arguments of various philosophers. And once you kind of intuitively get the difference between a necessary condition and a sufficient condition, then you've got it, and you see it everywhere. And you can pick these things out of arguments and see why they do or do not work, why they succeed or fail at either or both necessity or sufficiency. So let's go back to S1, syllogism 1. All humans are mortal. Socrates is a human, therefore Socrates is mortal. In order to get to the conclusion of this argument, you need both P1 and P2. You need to establish both that all humans are mortal and that Socrates is a human. Both premises are absolutely necessary in order for the argument to get off the ground. If you're going to arrive at the conclusion, you got to have those two things. They're necessary. You lose one of them, doesn't work. You substitute it with something else, it doesn't work. You turn Socrates into a cabbage, boom, the whole thing. I mean, it'll be invalid, but it also, you've lost the necessary components. Necessary conditions are conditions without which you do not get, like either one of them not being present means that you don't get the conclusion. Therefore, we can say that P1 and P2 are both necessary conditions to establish the truth of C. So necessity means you have to have it. You can't not. Right. Further, if you have P1 and P2 together, you are guaranteed to get C. You don't need anything else. And this is, we're moving into sufficiency here, by the way. if you have P1 and P2 together, if you have the two statements that all humans are mortal and Socrates is a human, you've got Socrates is mortal. That is enough. You are guaranteed to get C. You don't need anything else. They're good enough, those two premises by themselves. And that is the criteria of sufficiency. We describe this by saying that P1 and P2 together are jointly sufficient for establishing C. So, in this case, P1 and P2 are both necessary. You can't get rid of either one of them. You can't lose either one of them. You can't switch it out with something else. You have to have them in order to get the conclusion. But they're also sufficient. Once you have them, you don't need anything else. You are guaranteed to get the conclusion if you have these two premises in place. So, the premises that constitute syllogism 1 therefore represent necessary and sufficient conditions for establishing the truth of C. If you can logically prove that you have discovered the conditions that are jointly both necessary and sufficient for the truth of something, congratulations, you have solved philosophy, and you can take the rest of the day off. You can go have a beer and play pool with David Hume, because you've done it. That's the Holy Grail. It's what we're all trying to do. We're trying to get that argument that establishes both the necessary and sufficient conditions for whatever it is we're trying to prove. And once we've done, if we're successful in doing that, then we have said all that needs to be said about about whatever the thing is that we're talking about. And it is extremely hard to do this for something that is significant and non-trivial. So it doesn't happen very often. But who knows? Maybe one of you guys will do it in the next month and a half. So, a condition can be necessary without being sufficient, and vice versa. So, consider the following statements, and we're going to be doing some conditional sort of if-then kind of stuff here to try to demonstrate. And again, please follow along with the text. It'll be much easier to sort of see how all this fits together. Beyond just the melodious sound of my voice into this microphone. So, consider this statement. Being a reptile is a necessary condition for being a lizard. Again, being a reptile is a necessary condition for being a lizard. That's true. That's a necessary truth. It's impossible by definition to be a lizard without being a reptile. That's what lizard means. That's part of the definition of lizard. But let's look what happens if you reverse that. Being a lizard is a necessary condition for being a reptile. Okay, so the first one was being a reptile is a necessary condition for being a lizard. Second one, being a lizard is a necessary condition for being a reptile. We've just switched out lizard and reptile in this case. And it's wrong. It's radically, drastically, incomprehensibly wrong. There are tons of things that are reptiles that aren't lizards. Alligators, for example, are reptiles. The set of all things that are reptiles includes way more than just lizards, and therefore, being a lizard does necessitate being a reptile, but being a reptile does not necessitate being a lizard. You can be a reptile without being a lizard. Being a lizard is not a necessary component of reptileness, of reptilianness. So let's try the same trick for sufficiency and see how it works there. So being a reptile, we're sticking to reptiles and lizards here. It's one of the classic sort of examples. Being a reptile is a sufficient condition for being a lizard. Well, that's also wrong. Turns out, since we know that there are reptiles that aren't lizards, we already covered that. We also know that we know because of that it takes more than just being a reptile to make something a lizard. You need something more than reptilianness to establish lizardness. Reptilianness also applies to alligators, possibly dinosaurs, although I feel like we've moved them more into the bird category since I was a kid. Point is, being a reptile is not sufficient for being a lizard. You can be a reptile and be tons of stuff that aren't lizards. So, but let's switch it around again. So the last one was being a reptile is sufficient for being a lizard. That's wrong. Being a lizard is a sufficient condition for being a reptile. What about that? Well, that's true. If you're a lizard, you've established that you're a reptile. Boom. That's all it takes to be a member of the set of things that are reptiles, is to be a lizard. If you are a lizard, you have guaranteed that you are also a reptile. It is impossible to be a lizard and not be a reptile without radically changing what the words lizard and reptile mean. So that is just an example of how sort of the direction of these arguments matters, and how sufficiency, and I really want to try to peel these two apart, because it's very easy to get necessity and sufficiency sort of mixed up. And here's another thing that makes them complicated, is that the statement being a reptile is a necessary condition for being a lizard, and the statement being a lizard is a sufficient condition for being a reptile are equivalent statements. And this works across the board. A is a necessary condition for B is always logically equivalent to B is a sufficient condition for A. It's called logical equivalence, and it's always going to hold. Any statement A is necessary for B will always be logically equivalent to the statement B is sufficient for A. So that again makes these things tricky. So the direction matters. Take your time with them. They're tricky. Logical fallacies. I'm not going to spend a lot of time on logical fallacies. There's a really good article in your readings in the textbook on logical fallacies. I think it's the Stephen Barker reading. But really quick, because this one's going to be important, we'll deal with one logical fallacy. And let's return to syllogism 1 again. Premise 1, all humans are mortal. Unfortunately. Premise 2, Socrates is a human. C, therefore, Socrates is mortal. So let's try that logical equivalency trick and reverse the terms around. Let's switch around some terms in syllogism 1. And this is going to give us syllogism 4. Premise 1, all humans are mortal. Premise 2, Socrates is immortal. Conclusion, therefore Socrates is a human. Now on the surface, that looks like it works, right? All humans are mortal, Socrates is mortal, therefore Socrates is a human. But it doesn't work. It's actually deductively invalid. And the reason for this is that there are plenty of things that are mortal that aren't humans. So you say all humans are mortal, Socrates is immortal, therefore Socrates is human. Well, I mean, it's true that Socrates is mortal, but it's not established by this. The inferences do not lead to the conclusion. Someone could have a cat named Socrates that is also mortal and is not a human. And this is called affirming the consequent. So the way these syllogisms are set up, look at premise 1. So premise 1 is all humans are mortal. The term human here is known as the antecedent, and the term mortal is known as the consequent. So all humans, human is the antecedent, mortal is the consequent. So this is affirming the consequent. So what we want to do is affirm the antecedent, which is human. But by affirming mortal and by switching that order around, we have kind of broken the inferential relationship that establishes the validity of the conclusion, because there are way more things that are mortal than humans. So establishing that Socrates is mortal doesn't assure us that he is a human. That's the thing. We've established that he's mortal, but we haven't established that he's a human. So he doesn't belong to the set established in premise 1 of things that are human necessarily. He could, but we could also be talking about Socrates the cat, or perhaps Socrates the cabbage. We don't know, and therefore we don't get the certainty that logical validity provides. So that is affirming the consequent is the name of that. And we will come back to an example of that later on. So that's a logical fallacy. A logical fallacy is an error in logical reasoning. And there's two types. Logical fallacies can be formal or informal. Formal fallacies, such as affirming the consequent, are deductively invalid. That means the way that they're structured, the formal structure, doesn't work. It fails to guarantee the truth of the conclusion. Most fallacies are not formal fallacies. Most fallacies are informal fallacies. And these are things like black and white thinking, appeal to authority, ad hominem. I've attached a list, like sort of a chart of various logical fallacies you can take a look at. Look at the text. It's got a lot of lists of those. I'm not going to go through them. You're not going to be tested on like all of the logical fallacies for this course, but they are fascinating. And if you know them and know to look out for them, you will see them everywhere. But just because an informal fallacy exists in someone's argument doesn't mean that they're wrong. And that's actually known as the fallacy, where you're like, no, your argument is false because you made, an inappropriate appeal to authority or an appeal to an inappropriate authority. Well, that's true. The argument was bad, but that doesn't mean the conclusion's false. That's the fallacy. So, yeah, recursion. Okay, so that's some basics of deduction. And again, deduction proves the certainty via these inferential relationships, proves the certainty, establishes the absolute certainty of the conclusion. Cool. Inductive reasoning. While deductive reasoning works from the top down, inductive reasoning works from the bottom up. You start with particular instances, evidence, particular pieces of evidence or experience, and you derive from them a general conclusion, a general principle. So instead of going from the abstract to the concrete, you're going from the concrete to the abstract. Without induction, science would be impossible. Science works on induction, and we're going to talk a lot about inductive reasoning over the next couple of modules. It's a big topic within philosophy and a big source of controversy. And the reason that you need it for science is because you need it to learn new things about the world. You need to be able to appeal to observed evidence of experience in order to establish new knowledge. In order to gain new knowledge about things, you need to have novel experiences. You need to test things. And here, as an example, we witness patterns in nature. We see things happening again and again. Things recur. What will be called in the next module constant conjunction, where things just continue to happen one after the other. We drop a glass and it falls to the ground and shatters, right? We drop 100 glasses. We're having a very bad day at our waiter job or our waitress job, and we drop 100 glasses and they all fall to the ground. We conclude that these experiences are telling us something important about the relationship between things being dropped and things falling to the ground. If it keeps happening over and over again, something's going on there. This shows us that there's some sort of regularity in nature, some sort of perhaps natural law at work. Deductive reasoning makes no such appeal to experience, and this is one of the big differences between induction and deduction. Is that deduction you don't have to test deduction against the world. If you understand the terms used in a logical syllogism, you slot them correctly into a valid syllogistic form, and boom, out pops the conclusion. It's mathematic. So deductive reasoning tells us nothing that was not already implied by the definitions of the terms and their logical relationship. If you clearly define your terms and you know the correct forms of a syllogism, and we're not going into it's way more complicated than just the forms we looked at above, but we're not getting that deep into it. This is not a logic class, but if you have that, you're going to get the conclusion. You don't need to test it. You don't need to go to the world and test whether all humans are mortal and Socrates is a human, therefore Socrates is mortal. You don't have to test that. If you understand what the words human and mortal mean, and Socrates as an example of a human, then you get the result. It's true by definition. This type of knowledge, backing up a little bit, deductive reasoning provides certainty, but it is a narrow certainty that is concerned only with form and indifferent to content. And again, this form-content distinction really goes back to Aristotle. We're not going to be belaboring it too much in this course, but it is important to philosophy in general. That form refers to the structure of things, or the mathematical, what Hume will call in the next module, relations of ideas, the way things relate structurally, versus the content, which Hume will call matters of facts, facts about the world. So this type of knowledge that deductive reasoning deals with is sometimes called a priori knowledge, from the Latin, from what is earlier. The word prior comes from this. Prior meaning earlier. Knowledge is a priori if it can be arrived at prior to and independent of our experience of the world. You don't have to check it against the world. You already know ahead of time that, something like all bachelors are unmarried men. You know that without checking it against the world, because you know what the words mean. And although it gets more complicated, and when we get to Kant, that will come back, that particular example. So if we want to learn new facts about the actual content of our theories, we have to test them against the real world. We are forced to arrive at this knowledge inductively, that is, through experience. This type of knowledge is sometimes called a posteriori knowledge, from the Latin for from what is later. It's knowledge that is arrived at after or as a result of experience, and that's the big difference. Is that deductive knowledge you do not have to test against the world. Inductive knowledge you have to test against the world. You will arrive at this knowledge through experiences in the world. And that's why it's a posteriori. It's after experience. But there is a trade-off, and we've already sort of spoiled this, but induction can expand our knowledge of the world, but it can never provide us with absolute certainty. It doesn't give us the certainty of deductive reasoning. It gives us new knowledge, but it doesn't give us certainty. If you see 1,000 white swans over the course of your life, and never a swan of any other color, you would be justified, based upon the evidence, in making the inductive inference that all swans are right, and you would be wrong, because black swans exist. They're rare, but they exist. And that's the thing. As Albert Einstein, he summed it up in the way he often does, very succinctly and very pithily. No amount of experimentation can ever prove me right. A single experiment can prove me wrong. No matter how much evidence you observe, there could always be another example that disproves the hypothesis. There could always be one more thing. You can't test everything in the universe. You can't even test everything on Earth. In your whole lifetime, in the lifetime of all humans, we will not test everything on Earth. We will not come anywhere close to testing everything in the universe. Unlike the certainty of a valid deduction, unlike the certainty of a valid deduction, induction can only ever increase our confidence, which is sometimes called credence. Credence is sort of a term of art within philosophy for our amount of sort of confidence in an assertion. So it increases the probability, it corroborates or increases the probability that a hypothesis is true. If you confirm it over and over again, you test it again and again, you keep dropping the glasses, you keep seeing the white swans, and all of this provides evidence that raises the probability that dropped glasses will fall and swans are white. One of those things is true, one of them isn't. And that's the thing, is that outside of the set of things that you've tested, there could always be another example that if you found it, if you tested it, would prove it wrong. You never know. And let's move into now more directly into the philosophy of science. Induction leads directly into the philosophy of science because science is based on inductive reasoning. And that was sort of a big part of the scientific revolution, was shifting to using experience of the world, which is actually a fairly revolutionary idea at the time. if you look at everything Galileo went through to sort of establish the notion that, hey, if we look at the world, we see that it does this, up against an orthodoxy that said, no, that's not true because Aristotle, 2,000, 3,000 years ago, said it does this. And we believe, what are we going to believe, Aristotle or the world? Pfft, come on. But the scientific revolution and everything we have as a result of that comes from the sort of rise of induction as being a valid way of arriving at a conclusion. So let's talk about Carl G. Hempel. And to talk about Carl G. Hempel, I'm going to contextualize him within the sort of background of the School of Logical Empiricism. We're not going to go deeply into logical empiricism. It's not going to be on any of the tests or quizzes or whatnot. But it is context for why Hempel's included here and why he's important. And what he's doing. Why is he talking about this stuff? Why is he telling us the sad, sad story of Ignaz Semmelweis? So the German philosopher Carl Gustav Hempel is most closely associated with the school of early 20th century philosophy known as logical empiricism. It was actually first known as logical positivism, but later as logical empiricism. You don't need to know that part, or why that's different. The logical empiricists were inspired by Bertrand Russell's efforts. Here's Bertie again. Here's Bertrand Russell again. Like Bertrand Russell and Plato are going to be in the pebble in the shoe of philosophy, like always going forward. You're never going to get rid of these guys. The logical empiricists were inspired by Bertrand Russell's efforts to reduce mathematics to formal logic, which is called logicism, was what that theory was called. As well as by the early Wittgenstein, Ludwig Wittgenstein, who was a pupil of Russell's, who insisted that all philosophical problems were just problems of the use of unclear language. Like if you ran into a problem of metaphysics or ethics or of ontology or any of these sorts of things, ultimately what was happening is you were just being unclear in your use of terms and language, and you needed to more clearly define your terms. And that was a hugely influential position that changed the course of philosophy for the 20th century and basically turned philosophy into philosophy of language for about 100 years. So Wittgenstein, we're not going to go over him in this course because then it would probably just turn into a Wittgenstein course. That's what happens. Very, very smart, very important, very complicated, very difficult philosopher, both as a philosopher and as a person. So these two projects, particularly Wittgenstein's notion that philosophical problems are ultimately just people not using language in a clear or consistent way, was influential to the forming of the logical empiricism. It started with the Vienna Circle, and you don't need to know the full history of this. And they were also inspired by a lot of scientific things that were happening at the time. This was around the time, or shortly thereafter, that Einstein's theory of relativity and his early atomic theory had been published, both special and general relativity. So there were big changes that were happening, and these sent ripples throughout philosophy and showed that the value of both experimentation and therefore induction, but also of being able to situate evidence and experimentation within a logical form so you could get something like certainty out of it. So building upon these projects, the logical positivists, I should have changed that to logical empiricists in this draft, but whatever. Means the same thing in this case. Sought to develop tools that would clearly separate statements that were meaningful from statements that were meaningless. So what they're trying to do is do what's called demarcation in philosophy, find some principle that's going to distinguish statements that have cognitive meaning, that mean something, that are clear, and that can be directly analyzed and logically tied to the world, connected, that hook onto the world in a very clear and precise way, from statements that were meaningless, from statements, and they were particularly not fans of metaphysics and thought metaphysical statements were just kind of meaningless. Wittgenstein, I think, talked like language spinning its wheels. And early on, to this end, their primary tool was a famous principle called the principle of verifiability, which states that a statement is meaningful if and only if it can be, in principle, verified by observational evidence. So if you can test a statement against the world and verify it, then it's a meaningful statement. If you can't do that, if there's no possible test that could verify your statement, then it's nonsense. You're not saying anything. You're not even wrong. You're just not saying anything coherent. You're making sounds, and that's all you're doing. So the verifiability principle was ultimately doomed for at least two reasons. First was the problem mentioned above, that there's just no way to verify conclusively any inductive statement. There's always going to be another possible counterexample out there. Second, and more damningly, was the fact that the verifiability principle appeared itself to be in principle unverifiable. There's no test, no observable test that you can perform that will verify the verifiability principle. And since the whole point was to determine whether a statement was meaningful or meaningless, that kind of kills the theory. So by its own standards, the verifiability criterion appeared to be meaningless. Good job. You've proved your own theory to be meaningless. That's an accomplishment, right? So with the verifiability principle out, the focus shifted to falsifiability. And this is where a guy named Karl Popper comes into the picture. He's, again, you're not going to be tested on Popper. You don't need to know a lot about Popper. But he sort of sets the stage for Hempel. Karl Popper suggested a much narrower test to distinguish not between meaningful and meaningless statements. That's too broad. But between scientific and pseudoscientific statements that were scientific, and statements that looked scientific, that looked sciencey, but were not actually scientific statements. And this is called the demarcation problem. It's still hotly debated. Some people think that Popper got it right. Some other people think that he didn't get it right. According to Popper, string theory gets ruled out, for example, because string theory is not falsifiable. In 60 years, no one's come up with a test for it. More than 60 years now. So, a statement, and it's sort of like it's the inverse. The falsifiability principle is basically the inverse of the verifiability principle. A statement is scientific if and only if it can, in principle, be falsified by observational evidence. You can't verify something, and this goes back to Einstein's statement. 100 tests can't prove me right, but a single test can prove me wrong. You can inductively falsify something if you test it, but you can't verify it. You can't confirm it. You can corroborate, but you can't confirm. This brings us to the deductive nomological model. Hempel, honestly, was just terrible at naming things. The deductive nomological model, the hypothetico-deductive model, just this hyphenated, kind of Latinate, overly complicated, and both of them reduced to like two initials with a dash that have a D in them. It's again, they're not going to be on the test. It is important to understand what he's describing, particularly as it relates to testing what's called the test implication of hypotheses. But you don't need to remember which one's the deductive nomological and which one's the hypothetico-deductive model for anything that you're going to be getting a grade on. Unless you're just, like me, really interested in this stuff, and particularly this period of philosophy, in which things were often named in unnecessarily complex ways. So the previous principles of verifiability and falsifiability both put a lot of emphasis on gathering and testing observational data, observational evidence, testing things. So if you're going to use those kind of tests, you need to really get clear and specific about what you mean by observational evidence. Excuse me. What criteria makes something count as observational evidence? And this is what Hempel was trying to do. So looking at the inductive practices of actual scientists, Hempel was inspired to attempt to formalize the process through which scientific experiments explain events based upon evidence. So he was trying to take the scientific method and formalize it, to create a logical model out of that. He was trying to deductively explain deduction and merge these two things, which is extraordinarily ambitious project and an influential one. It's still kind of the standard to this day. I mean, there's arguments against it, but like when people describe the scientific method, it's usually something like the hypothetico-deductive method that they're describing. So the method he developed was the big method was the deductive nomological model. That's the covering law model. That's sort of his big idea that he's known for. The DN model is shortened to the DN model because that's just easier to say than deductive nomological. Nomological, by the way, comes from the Latin for law-like, or law, which is nomos. So we know what deductive is, and now we know what nomological is. And so deductive, deducing things from a law is what that comes down to. The DN model begins by identifying the question that requires explaining. So you're trying to explain some problem. This is called, in Hempel's model, the explanandum, another Latin word that I think makes things more complicated than they should be. You produce, on the basis, so you have your explanandum, you have your problem that you're trying to solve, and then you produce a set of explanatory statements to explain it, and that's called the explanans. Explanandum, explanans. Again, two words that are Latin and long and sound very similar. Explanandum is the problem. Explanans is the thing that explains it. Explanandum is the thing to be explained. Explanans is the thing that explains the thing to be explained. That's the relationship. Some philosophers are really good at naming stuff, like catchy, pithy things, like David Chalmers and the hard problem of consciousness. That sticks, that pops. It really is a hard problem, so it's a good name for it. But Hempel will never work in marketing. Anyway, which to his credit, perhaps. The explanans, which is the bit that explains the explanandum, the problem, consists of two parts. First are the initial conditions, which is the relevant observational facts. That for whatever the problem is, you look at the facts of the case. You're an investigator, you're a scientific investigator, you look at the facts. What's going on? What are the variables? What are the different variables here? And from these facts, from these initial conditions, from these variables, you formulate a general law. You derive that, and what it's meant to express is a universal hypothesis that covers all similar observations. So what you're looking for is something universal. You're looking to derive from the initial conditions some law, some general universal hypothesis that applies universally to anything of a similar nature. You're trying to get universal laws out of this. And for this reason, the DN model is sometimes called the covering law model, which was actually a term applied to it by one of its critics, but was a much easier to say name, so it stuck, and is honestly a better name. Once the explanandum and the explanans have been established, these can be slotted into a deductive argument that produces an explanation that is both logically valid and falsifiable by empirical testing. So you get to have your cake and eat it too. You get logical validity, you get soundness, you get falsifiability. So you satisfy Popper's falsifiability criteria for a true scientific statement, and you learn something new about the world. This is a way to ground science in logic. And people still debate whether or not it was successful in doing so. But it's missing some pieces, right? Because you've got your initial conditions and you derive a general law from them. That's cool. How? How do you do that? Hempel still needs a rigorous methodology for testing his covering law model against the facts of the world. You still, how does that look? How does the process of testing look? And this is the important part. This is what we've been building up to in the Hempel section, and this is important for the stuff that's going to be graded. So here, Hempel turns to the equally terribly named hypothetico-deductive model, the HD model of scientific hypothesis testing. So deduction and hypothesis combined. Yeah, I mean, you guys can put together the puzzle pieces for that name. The DN model, the deductive nomological, articulates the logical form connecting a phenomenon, which is the explanandum, and its explanation, the explanans. Explanans. Again, formal. That's the form. That's the deductive form. But it doesn't tell us how we're supposed to derive a general law from a set of initial conditions. How do we do that? That's like, you have initial conditions, and boom, a miracle occurs, and you've got a general law. Well, how? And that's the job of the HD model, is to... microphone. That's the job of the HD model, is to tell you how. And it's what it does is it operationalizes the theory, which means it puts it to work and provides the actual content. So the DN model does the form, the HD model plugs in the content. That's the idea. So the HD model begins with the initial conditions of the DN model, and upon the basis of these, this is going to be a brief, sort of like 30,000 foot overview, and then we're going to do the Semmelweis stuff where we get down to sort of the specifics. So, but at the view from 30,000 feet here is the HD model begins with the initial conditions of the DN model. Upon the basis of these conditions, the scientist constructs some hypothesis, which, if true, would provide an explanation for these conditions. So you've got your initial conditions. On the basis of those, you look for variables that can be tested, and you form a hypothesis. Like, well, let's look at these. If we do this, then this will happen, and that provides the explanation that if this, then that. Next, the scientist derives a set of predictions from the hypothesis. So we have these initial conditions. What if we try this? Will that change something? And we test the hypothesis. The hypothesis that that the initial conditions plus prediction here will somehow produce a change. Will either successfully or will either succeed or fail when put to the test. So you derive a set of predictions from the hypothesis, which, if proven false, would falsify or disconfirm the hypothesis. Again, you're looking for falsifiability. You're looking for a way to disconfirm the hypothesis. You are trying to prove it wrong. You'll never prove something entirely right, but you want to eliminate the bad ideas so that what you're left with is the good ideas. And the predictions are known as test implications. Again, that's an important term to keep in mind, especially when you get to the quiz. So predictions are called test implications, which is what the test implies. It's the implication of the hypothesis. So what you're testing is what is implied by your hypothesis. Right? Simple enough. Finally, the scientist runs a series of tests which attempt to disconfirm the test implications that are generated by the hypothesis. So that's the general form, and it's an iterative process. That means you do it over and over and over again. If the predictions fail the test, the scientist returns to the starting point of the initial conditions, begins the whole process of hypothesis construction over again, and goes through and generates the test implications and tests them, and if they fail, then you go back to the start, and you keep doing that until something fails to fail, until something survives the test. And as you do that, as predictions survive the test, then the hypothesis moves one step closer towards confirmation as a covering law. This is the idea, and as we've already seen, you're never going to get confirmation. You're going to get corroboration. But you're trying to explain the initial set of conditions that trigger the investigation, and the idea that this gets you closer to that. So the example that Hempel uses in the text is the sad case of Ignaz Semmelweis. Semmelweis is yet another one in the whole line of revolutionary thinkers who were prosecuted by the authorities of their time for the crime of coming up with an inconvenient good idea. So in this case, it was the germ theory, which ran counter to the orthodoxy of his time. Doctors didn't like the insinuation that they were covered in germs. I mean, after all, they are wealthy professional men who have a high status. Germs are for poor people without degrees. It's insulting to insinuate that a doctor coming from a morgue to a maternity unit should wash his hands like some kind of dirty person. And genuinely, that seemed to be the thing that rankled, and which is a great example of how evidence, even fairly conclusive evidence, can be just ignored if it's inconvenient to sort of the dominant ideology of the time, or or embarrassing to people whose status depend on it not being true. So I'm not going to go into all the biographical details about this. There's 2 videos linked under the learning materials section. If you have not found the learning materials section, by all means, find the learning materials section, go through the modules, and go through this stuff. Watch the videos. There's tons of YouTube videos that we're linking here, and I'm adding supplemental videos and materials, and also in the focus topics that I'm sending out. Utilize these resources. They're very short. There's 2 videos there on the whole Semmelweis case. One of them, the second one, linked here, takes a weird turn at the end into some sort of religious proselytization that's like kind of out of nowhere and sort of left field. When it gets to that, you can just you can skip that part of the video. It's like there's nothing to do with washing your hands in Semmelweis's case. It has nothing to do with original sin. Despite it's a weird video. I'm gonna try to get it changed for the next version of this class. If I can find another. I mean, unfortunately, the rest of the video explains things really well. So instead, I'll try to slot the details of Semmelweis's experiments into the structure of the DN and HD models. So that's what we're going to look at. The problem for Semmelweis was the large discrepancy in mortality rates from puerperal fever. I don't think I've ever successfully said that. Puerperal fever? Childbirth fever. Between 2 similar maternity wards. So you've got two wards. One of them has a high mortality rate. The other one has a low mortality rate. And everything seems to be very similar between the 2. And this represents the problem, the explanandum that is calling out for an explanation or an explanans. So to go back to Hempel's kind of clunky terminology. To establish the explanans, Semmelweis considered the set of initial conditions surrounding the spread of fever in the 2 wards, which is to say he looked at all the variables, anything that could be different between what they were doing in this ward and the other ward, Ward A and Ward B. What were the differences? What were the things you could test? What variables between the 2 could be altered to see if that would produce a change in the outcome? And that's what you're looking for. You're looking for something that changes the outcome. One of these was the position of the mothers during delivery, which was different from one ward to the other. So Semmelweis formulated the hypothesis based on that. That's the initial conditions. That's the variable, the position of the mothers. That's your initial conditions, your variable. On the basis of that, you form a hypothesis that the difference in position is influencing the mortality rate somehow. Then you formulate a test implication, which in this case is that if you change the position of the mother so that they match in the 2 wards, before it was different, now you want it to be the same, and you see if that changes the numbers. You see if eliminating that variable eliminates the discrepancy in mortality rate, right? And then you test this you ensure that the mothers in both maternity wards are in the same birthing position, and you analyze the results. You see if that made a difference. You see if that mattered to the result. In this case, there was no significant difference in the outcome, so Semmelweis considered the hypothesis to be disconfirmed and returned to the initial conditions. This is that iterative process where if it fails, you go back to the beginning and you look at other variables. You try to find something else you can test. And you form a new hypothesis on the basis of that. And we can model this syllogistically. We can reduce this to a set of premises and a conclusion. Again, premise 1, if birthing position influences mortality, then changing the position will affect mortality. Premise 2, changing the position does not affect mortality. Conclusion, Therefore, birthing position does not influence mortality. That follows. That's a valid logical procedure. That's called modus tollens. If A, then B, not B, therefore not A. Modus tollens is essentially the inverse of the logical fallacy we talked about earlier called affirming the consequent. And for that reason, it's sometimes called disconfirming the consequent, which is probably an easier thing to remember than modus tollens. There's another one's like modus ponens, and I always get those two confused. Because again, I know some Latin, but I am not a native Latin speaker, nor is anyone else who lives, but at least in modern times. But it's that difference, and again, it's because you can you can falsify something, but you can't conclusively verify it. So you can say that changing the position doesn't affect mortality. It did not produce the change that you were looking for, therefore you can rule that out. You have disconfirmed the consequent, and again, the consequent is the second half of that P1. Then changing the position will affect mortality. That's your consequent. You have disconfirmed that. So you can move on. You can restart the iterative process. And he did, again and again. He moved through a bunch of different hypotheses. You can read all about it in Hempel's paper and listen to it in the videos. I recommend you do. And also there's the PowerPoint. I want to make sure folks are aware of the PowerPoint as well, which gives point-by-point breakdowns of all this stuff. The reason that modus tollens is valid while affirming the consequent is invalid is the same reason that absolute falsification is possible while absolute verification is impossible. A single test can refute a hypothesis, but no amount of tests will ever decisively confirm a hypothesis. Gonna keep hammering at that point. That's an important point. So scientists and philosophers, therefore, will often appeal instead to an inductive principle known as inference to the best explanation. So what does that mean? That's another sort of term of art within philosophy and science. So the results of experiments can never decisively confirm a hypothesis, but what they can do is provide what's called corroboration, which is, again, proving another example that suggests that this is true. Since it survived the test, you're building up credence. You're building up your confidence in the probability that this is the answer. You're making it more probability. It's a probability raiser. And once a sufficient number of competing hypotheses have been ruled out, the other stuff that failed the tests, then you are justified in affirming whatever remains, whatever hypothesis remains that achieves the best fit with the observational evidence. Sometimes there'll be a bunch of them. And you have to sort of come up with additional criteria to try to determine, and that can be simplicity, that can be coherence, that can be how well it fits with other scientific theories. And this is one of the big things as an ongoing discussion in the philosophy of science is okay, you falsified a lot of bad theories, but you have a lot of other theories that remain that are competitors for being accepted as the right theory. How do you determine between those? And we're not going to get deep into that though in this class. But to me anyway, it's fascinating stuff. In the Semmelweis case, the variable that ultimately resulted in changing the outcome of the test was the lack of proper sanitation routines by the doctors in one ward moving directly from the morgue to the maternity ward. Nowadays, we recognize that that is like gross and incredibly negligent. But they didn't know. They didn't know about germs. They didn't have a germ theory at that point. This is pre-germ theory. And we can syllogistically model this result as well. To hammer the syllogism home yet again. Premise 1, if improper sanitation increases mortality, that's your antecedent, then improving sanitation practices will decrease mortality. That's your consequent. Improving sanitation practices decreases mortality. So you have affirmed your consequent. Therefore, improper sanitation increases mortality. That's your conclusion. But as we can see, that is a clear case of affirming the consequent. Yet, germ theory is based on this argument, and it's held to this day. There have been many attempts, some very highly publicized attempts, to disprove germ theory over the years, and they've all failed. Germ theory is held. It may hold to the end of time. But since it is an argument based on inductive reasoning, it will never provide absolute bulletproof certainty regarding the germ hypothesis. All we can get, it's an inference to the best explanation. It fits the evidence best. It is highly corroborated by a series of tests that sought to falsify the test implications that were based on the hypothesis that were implied by the hypothesis. And it survived all of those. It could survive all of those forever. And this type of process is called, sometimes referred to as an asymptotic process. And this is kind of a mathematical term. An asymptotic process is something that approaches, in this case, certainty. It approaches a point. It goes like this. It's trying to get up here to certainty. Certainty's up here, and it's trying to get up there. And it gets closer and closer and closer. It gets infinitely close, but it never reaches it. It never gets there. And that's what an asymptotic process is. It can keep moving closer and closer and closer. The more things you falsify, the closer you get to the truth. But you never get to the truth. You never find capital T truth out there. You eliminate the bad ideas. That's how you get closer to truth, not by finding the one true theory. There may be a way of finding the one true theory, but we haven't figured it out yet, and it's unlikely that it falls within the domain of science, because that's not what science does. Science does inductive hypothesis testing. Philosophy deals with more abstract things. It deals more with deductive logic and things like that, and it also deals with sort of abstract questions about the nature of truth and the nature of being and the nature of the good, all the stuff that Plato was concerned about back in the day and that we'll talk about moving forward. So that sort of consideration typically falls within philosophy. That's one of the reasons we're still talking about it 3,000 years after the early Greeks, after the Socratics. And the pre-Socratics, is because it's very hard to do, and these are the questions that we don't have a method for arriving at absolute truth. So anyway, that is deduction and induction. There are some other articles that are important. There is going to be a question on the quiz related to the anti-scientism article. I highly recommend as well the articles on logical fallacies, which is I believe it's the Stephen Barker article, Improving Your Thinking. And there's one by Janet Corney, which is on the social context of science, which there's going to be a thread of sort of feminist philosophy critiques moving through the modules that create kind of a through line, and that I think when you get to your final paper, that's something you might want to look at, because what these do is they sort of critique and unpack a lot of the assumptions that are hidden in these big theories that a lot of philosophers who historically were men, because of the way society was structured in those times, and the lack of women's rights throughout a lot of the periods we're covering. So female voices were left out of this, and a lot of things were not considered as a result of that. And not just women's voices, a lot of other voices were left out of there. We're dealing with the history of Western philosophy, which ignores the vast majority of the world. There is a lot of incredible stuff in Middle Eastern and Eastern philosophy and African philosophy, etc. As we move into the 21st century, we are trying to correct for that within the field, and I think making some tentative progress in that direction. And some of the feminist philosophers that we'll be looking at in our readings, it's not stuff that's going to be directly on the tests, but it's stuff to keep in mind for your final paper. And I think the Kearney article on the social context, one of the things specifically is funding. We tend to think of science as sort of this impersonal, objective practice that swings free of politics, but no, it's all run by funding. It's you cannot, if you produce a null result or what you demonstrate through testing does not make the people who have the money happy, you're not getting published. You're not getting it out there. Your university is not getting money for that. Your tests are not going to be funded, and that's not going to get out there. There are politics at work behind the scenes which decide what experiments do or do not get performed, and then do or do not get published. So it's important to keep that in mind. And a lot of the stuff we're going to look at are people sort of with not acknowledging that, sort of thinking that this is an objective process that's somehow ahistorical, that stands outside of time and place and culture and politics and emotion and biography and all of those things, and nothing does. I think Nietzsche and Foucault and guys like that do a great job of demonstrating that, and it's a very prominent critique within feminist philosophy, within continental and postmodern critiques within critical theory. That needs to be taken seriously, and I think is increasingly being taken seriously in the 21st century. But this wraps up this module. Please, take a look at the other modules. Take a look at the other learning materials provided. There is another existential comic at the end of this of the printed version, the PDF. I think I'm going to attach this one as a PDF rather than just like blasting out the whole lecture and an announcement. Take a look at that. Hopefully it's funny. Hopefully you got something out of this. Let me know. And see you in office hours, or shoot me an email if you have any questions. Otherwise, take care. Have a great week and good luck.